So my sessions, it's not continuous delivery if you can't deploy right now. So if you don't have a system that you can go and click a button and it goes to production, then you might have a really good continuous integration system, but it's not continuous delivery, is the basis of my hypothesis, I guess. So who am I? My name's Ken Mugrage. I'm a technology evangelist for ThoughtWorks, which doesn't really mean anything. I've been with ThoughtWorks for about 7 years. Started here as a sales engineer, was the program manager for GoCD for a couple of years, helping it move to open source and so forth. So, I mean, that's my background. It's Twitter if you want to follow me there, or if you want to reach out for any questions you might have that we don't have time to get to today or what have you. Very quickly about ThoughtWorks for anyone that's not familiar. About 25 years old, primarily a software delivery organization. So we write software on behalf of other people, or usually co-sourced with other people. A little bit of our background, we have people that signed the Agile Manifesto. Martin Fowler, our chief scientist, wrote kind of the definitive blog that formed continuous integration, what it is. Jez Humble and Dave Farley both worked for us when they wrote the book Continuous Delivery. So we have a little bit of track record here. Definitely not doing any product demos today. I know this is a vendor session. We have a booth on 5 if you want. We can do that there, but I'd rather talk about Meet here today. So why this talk? Frankly, it was born a little bit out of frustration. So I used to manage an engineering team, and I had a favorite pet peeve. It was like, hey, is this done? It's like, yeah, it's completely done, except for, or it's completely done, I just need to. It's like, okay, if there's a qualifier, then it's not done, and that's okay, but this is black and white. This is not gray. It's either done or it's not done. Okay, so why does this matter? We go back to 2001. 17 people got together at a ski resort in the United States and wrote the Agile Manifesto. And a lot of people have read the Agile Manifesto, and they know about doing incremental work, and et cetera, but not very many people have looked at page 2, which is the principles behind the Agile Manifesto, and this is the first 3. And you notice the first one is to satisfy the customer through early and continuous delivery of valuable software. So a lot of people think the term was coined when the book by the same title came out in 2010. It was actually quite a bit earlier than that. And we've been practicing things with continuous integration where we're getting good builds and development's really happy, but we're not actually delivering value to the customer. Why do we want to deliver constantly? Because partially done actually might still be useful. So if anyone's taken like a Agile 101 or whatever thing, you might have seen this diagram. This is not how you incrementally design a system. You can't design the first quarter and then do the next quarter, because picture number 2 really has no value. You're not going to see that in the Louvre, even though the other 3 are done really, really well. What you really do is something like this. You sketch it out, you add a little bit more, you add on it, and so forth. And a software system's the same way. If you read the Gartner and Standish and Forrester and those kinds of folks, they all have different numbers, but they'll tell you, 70, 80% of software features that we write are never used. So we want to deliver these features to our customers quickly, measure the business impact of that, not just how many milliseconds it took to load, but are we selling more widgets? And if we are, then we keep going. If we're not, we stop. But we still have something that's useful. So there's value to whoever, even if we don't continue to go. I mean, companies pivot, we change things, et cetera, but we don't have to throw it away. The other really big reason that you want to have things be able to deploy right now is respond to security issues. So, Heartbleed was one of the OpenSSL ones. There was Drown just last week. I didn't feel like updating the slide, to be honest. But, there's these things come out that are significant problems. What's it say? About 500,000 of the internet's web servers were affected by this one very high security risk. And systems that were really well maintained with continuous delivery and infrastructure as code and what have you, they updated some configuration files, deployed to production, and they were done. But it had to run through, this is the SSL library. This might affect the way you log in. It might affect the way the systems are communicating with each other. This could break a bunch of things if this new version doesn't work with your application. So it's important that even though you have to make an emergency fix, it still has to go through all of your tests. It still needs to pass all the unit tests, pass all the functional tests, pass all the et cetera, et cetera. Okay, and that's why you need to have a continuous delivery pipeline that's so important. You can deploy it at any time. Now, one of the ways that people accomplish to be able to deploy at any time is, I'm going to try get a little bit controversial here, is the concept of feature branching. So if I have a deployment branch and I don't touch it, other than, you know, when a little critical bug comes in, then I do a bug fix on it and I push that feature, that branch up to production. So that's my only change. And then when I'm done with my feature, now I merge that back into mainline. And you know, so that's a way that you can deploy right now. It's something that is valid, but we go the opposite direction. So on a feature branch, the idea is, so I know that's probably really hard to read. You have your main line there, and you've got Professor Plum on the bottom or top, and Reverend Green on the bottom there. And we have the main line, and they're working on their features, and you know, bug fix was done, and so they both pulled that code in and merged it in, and okay, that was easy. And then another bug fix was done, so they pulled that in and merged it, and again, that was easy. And this is all great, except for that it's actually a little bit of a race, because if Professor Plum commits his feature branch first, then when Reverend Green goes to do a merge, now I got the great big merge conflict, and I got a bunch of code that I have to fix, and et cetera, et cetera. Now, I used to work for the company that made Subversion, and they have great tools to survive merge conflicts. There's a lot of things out there to do that, but they only address the code of the conflict. This line is different than that line. Here's the conflict, fix it, make a decision. They can't address semantic conflicts. The intent changed. I don't want to do it that way. I want to do it this way. Okay? So when we say practice continuous integration, we believe that that means that you don't do feature branches. There are people at ThoughtWorks who I respect who would say that if you're doing feature branching, you are not doing continuous integration by definition. Those words mean certain things. You might be doing really good automated build and test, but you're not doing continuous integration, because that means you're integrating back to the mainline. So in fact, what they should be doing is at least once a day, Professor Plum and Reverend Green should be pushing their code to the mainline so that that code's always there. So in other words, the recommended practice is everybody commits to trunk, or whatever you want to call it, automate a test run for every commit, and we avoid branches. Okay, but you know, Ken, you just said I have to be able to push to production anytime. How can I do that if I got partially done features in the code base? So there's lots of different ways. I'm going to go into one of our favorite. So releasing incomplete work. There's this concept that we call feature toggles. And I'll go into what it means here in a little bit, but there's a common misconception that these are only for like small UI things, what I'm going to go into. So like we have a product though called GoCD, which is an on-premise CD server, and it's fairly old. It's been around since 2008, and it was on Rails 2. And we recently upgraded, about a year and a half ago, I guess now, to Rails 4. I mean, that's a really significant change to the code base, and it was done on mainline through these kind of concepts. So what you do in a feature branch is you have, you know, a function, does a thing, or sorry, a feature toggle, excuse me, and you change it. So you say, okay, here's my new function, and if use new algorithm equals true, then call it that one. If you use new algorithm means false, then call the other one. This is incredibly popular in systems you probably use every day. All the big retailers, all the big social sites, et cetera. There's a difference between deploy and release. They deploy the code that was written yesterday, today, or today, this afternoon, et cetera, constantly. But it's not released. It's not turned on. So you don't see the feature, but it's there. And feature toggles is one of the better ways to do it. And those actually can be grown up quite a bit. So you can do them automatically. This enables all kinds of stuff. I mean, again, what we're trying to do here, there's a DevOps firm where they say, what's the time from aha to cha-ching? And it's just, you know, from when you get the idea to when you're making money. And that requires doing metrics on the business. If you have things like feature toggles in place, you can deploy to certain parts of your audience. Like Facebook does their employees first. And that feature is turned on. And they look at their very good logs and see patterns and see click paths, et cetera, and decide, is this feature working the way that we want, need, intend it to? And if it's not, they roll it back, and that feature never goes to anybody else. But if it is, then they can turn it on. Or you could do geography, or you make your own choices. There's lots of different ways you can do that. So that's just one way that you can make it so you're doing your code on mainline, but still deploying all the time. Okay, a little bit of a transition now. This is the one where I say, oh yeah, I'm doing continuous delivery. I can deploy anytime. I just need to X. So usually what will happen is they'll say there's parts of the verification of software that are not done in the continuous delivery pipeline. So one of that I hear a lot is, yeah, I can deploy it, or it's deployable right now. I just need to have the security team sign it off, or I just need to do performance testing on it, et cetera. There are ways you can put that in your CD pipeline. So first off, there's lots of different concepts over here, different types of testing that we think you should be doing on every single build. I should say also that the idea of a deployment pipeline to us is to kill a release candidate. Every single time you commit code, push code, merge code, whatever you want to call it, every single time that is a release candidate. It is the pipeline's job to kill it, to say this one's not going to production. You can't prove something's good. You can certainly prove something's bad. Okay? So first thing we want to do, maybe this is even a pre-commit hook, something like that, is do some tests like, hey, are there private keys in here? I mean, there are people that somebody did a thing a couple of years ago where they scanned GitHub and they found hundreds and hundreds of private keys. And hey, guess what? They just got the keys to your kingdom. And even if it's accidental, if it hits anywhere for a microsecond, it's valid. It's invalid. You have to kill it. So those kind of tests even before it gets to your pipeline. This type of testing, so the static application security testing, it's Gartner. I use Gartner's term. This is to make sure that known issues, that kind of thing, aren't getting through. So Sonatype, who they make Nexus, they run Maven Central, so forth. They just did a huge study. Their CTO is a gentleman by the name of Josh Corman, and he did a presentation at DevOps Enterprise where they put this out. Their average one has 160 component parts, 24 on average of the Maven Central users, 24 of those components have known vulnerabilities that are rated critical or severe. And so, I mean, there are newer versions available. If their Maven config or whatever was changed to use those, then they'd use it, but they just don't know that. And yet there are well-known tools for doing these. I mean, Brakeman, there's lots of them. Like I said, we're on 5 if you want more detail. You should be running these tests on every single build. Then, of course, the dynamic stuff, tools that run against your code, but you actually have to do all the functional testing and stew, but also security testing. Can I brute force it? Can I try passwords as many times as I want? Is it respecting the password rules it's supposed to? Et cetera, et cetera. You should be testing these all the time. From a performance category, again, load testing. It's amazing. There's a statistic. I don't know if I wrote it down here. I didn't. But Amazon did a study that I think it was every 100 milliseconds of delay caused a 1% sales loss. And I might be wrong on the number, but it was something huge like that. So if a page takes 2 more seconds than it should, I mean, they're losing 20% of the people are going to say, no, I'm out of here. So it's really important. Also, things that come up in performance tests are typically hard to find. So if you're not running performance tests as often as you possibly can, then it could turn out that it's going to be a hard time to find these things. So stress testing, we do the upper, you throw it as much, you scale it until it breaks. Now you know your upper limit. Soak testing over a period, and then spike testing, just increasing their load all of a sudden. So, I mean, these are the typical kind of performance tests, and very rarely do I see these in a continuous delivery pipeline. I mean, less than 5% of the time. People will have good functional tests, they'll have good unit tests, et cetera, but almost never do they have real performance tests. They'll measure how long the Selenium suite took, which is an indicator, but they very rarely have real things, and it's usually because they simply take too long. I mean, a soak test, it's continuous expected load. Well, define continuous. Is it 3 hours? Is it 3 days? Is it et cetera? You certainly don't want your pipeline to take that long. And so that's one reason that people came out. So what we'd recommend you do in this case is take advantage of parallel processing, basically, and shorten this as much as you can. So the recommended pipeline pattern, so you have your build pipeline, if you will, the CI. So check out the code, do code style, do unit testing, et cetera. Make sure this is okay. You take that package, whatever's created from that, and you upload it to an artifact repository, a file system, whatever you want. And that is the exact binary that goes through the rest of your pipeline. You never build it again. You never go back to source code again, et cetera. You take that binary and you move it along your pipeline. And then you may bring that in and you may have, the typical integration test. Here's all the services, microservices in Docker. Oh yeah, Docker, 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 I have to do that. Now, those in that world, these things need to be tested and make sure they run together. But then you absolutely, whatever CD system and stuff you're using, should be able to go back out and do parallel, do other pipelines in parallel, but not move it any further until everything upstream has passed. So that verify stage, to give you one idea, this is just one example. I very well might have, the CI, the unit test, and then there's no reason I can't run these in parallel. While my functional test suites are running, if that takes 30 or 40 or 50 minutes, it shouldn't. You want the shortest you possibly can. But there's no reason I can't run fast tests like load and spike while that's running, other than cost of hardware or cost of resources, obviously, which is also getting better with containers and et cetera, et cetera. But I can run those in parallel. Some of the longer things, maybe I'm okay with going to staging and testing in a production-like environment before we're actually ready to go to production. I'm not going to go to production. I still put a dependency. If these fail, where fail equals something less than what you expect, you define pass fail on performance tests, we can still say, no, it's not going to production. We thought it was good. The load test was great. The spike test was great. But when we put it on a soak test, it turned out there was a memory leak, and eventually the whole thing crashed. So you can still put those in there and do them parallel. Yeah?
Do you expect to do it every build or every day or 2 days?
If at all possible on every build.
It takes much time.
It could. But it depends on, I should repeat the question because for the video and everything else. He's asking, is it on every build or every day or how often? And it's really as often as possible. So there's two terms that are used interchangeably and they shouldn't be. Continuous delivery is the ability to deliver at any time. You can click a button and deliver to your customers. Continuous deployment is truly deploying every one. If you're practicing continuous deployment, if you're deploying 20 or 50, 100 times a day, then no, you're not going to do that on every build, for sure. Okay? But remember, the more builds that go through before you run it, the harder it's going to be to find a problem. Because the more code you have to go through, et cetera, et cetera, et cetera. If you're practicing continuous delivery, where you're, say you have a packaged software product or something like that, and you're only going to deliver once a month or once every 3 months because package, download it, and install it on my system, you don't want to do that automatically. If Apple pushed an update to Keynote right now, I would be really upset. Okay, so there's things that you could say, yeah, it's not going to production anyway, so yeah, let's run it on every load. Now, what you want to do, though, is you have what's called a locking or automatic locking pipeline, which I think most CI/CD servers support. What that means is that it'll run until, it won't start another run until this one finishes. And then it'll pick up all the code changes since the last run and run another one. And so it might run way less often than these. Those might run 3 or 4 times for every one of those. But I can't push it to production until it runs. That make sense?
Partially, because I think in practical, in theory it's very nice, but in practical we tried it. We had a system test, and the developer just sat down and waited for it. So,
yeah, okay.
So it didn't work out, so we had to do it like every, we run it nightly. So.
Yeah. Yeah, so he was saying they tried it, but they had developers that would sit there and wait for the performance test. And I could see that, it shouldn't, but okay. And so they ran them nightly. And the truth is, that's probably fine unless you're, if you're a large enterprise and you have 1,200 developers committing code to the same, massive thing, then there's a lot of change in a day. If you're a smaller team, there might not be. It's, up to your risk. I can tell you that, this is kind of funny because when I stand up here, I have to tell you the way that, in a perfect world, this is the way it will be. We do not run a performance test on every version of GoCD. It deploys, we do a push every month. We run a performance test on, I don't know, every 10th build or so. And that's because our build agents are on private cloud and we don't want to use the infrastructure all the time. So it's also a matter of how much do I want to associate to this. Okay, so now if I'm pushing to production all the time and I can deploy at any time and I have feature toggles in there that is code that's not supposed to be executed, how do I, but it might be, how do I manage the risk? First off, I have to say that the need to manage the risk is a little bit false. Puppet Labs did a DevOps survey in 2014, 2015. If anyone was just in the CI/CD open spaces, John Willis was talking about it. And it was run by a few people, and one of them was Nicole Fosgren of Chef Labs, or Chef, sorry, it's not called Labs anymore, who was a PhD in statistical analysis or something like that. And like 20,000 results. I mean, everybody has said this is a statistically valid survey. What they found is the more deploys organizations did, the higher performing they were. And more deploys led to lower mean time to recovery. They could recover faster if there was a problem because the changes are smaller, frankly. And so it's actually true, statistically, that the more often you deploy, the less risk there is. That says not everybody believes that, so we have some ways around it. First one is from a deployment pattern perspective. So it's the concept of a canary release. If anybody knows mines in the old days, they would take a canary down in the mine. And if the canary died, then they left the mine. Because canaries have really tiny lungs, and the gas would kill them, frankly. And so they know, okay, this isn't going to work, and they left. Canary releasing, frankly, is about the same. You flip that feature toggle on a few machines, and you see what happens. Now, I come more from the systems side background than the programming side background. What we want to measure then is performance, response time, what's our memory usage, is our CPU spiking, et cetera. Don't forget to measure the business metrics. I mean, I think the people in this room are on software teams where you're trying to drive business to your companies of one way or another. Are you trying to make your company more efficient by updating your CRM system? Something. So do business metrics on your canaries. Say, okay, I'm going to release this to 10% of my audience, and I'm going to say, do sales go up or do sales go down over a 24-hour period? And if sales go down, you kill the feature. You take it back out, and we learned, and we're not going to deploy something that's making our sales worse. If the sales go up, then you keep rolling it out. And don't do that for security tests, please. The other one is dark launching. So this is actually really cool. There's a story, there's a link down at the bottom to this informant article is actually going to go to Facebook, I believe. So if you use Facebook, there's this messenger thing where you can message people back and forth and chat and what have you. And actually the article is about when they did it was a real name or I can't remember the exact feature. But they were going to release it all at once to 200 million users. And the question came back, well, what's going to happen when we do that? And they said, well, I don't know. So what they did is in the code, the features were hidden from the UI. You couldn't see it there. But when you as a Facebook user loaded the page, it made a request and called one of your friends, and your friend's browser got some JavaScript or whatever, and it answered you, and you were chatting with all your friends, and you had no idea. Okay, so the feature was live, it was in production, everybody was using it. They did a canary, they rolled out to the employees first, they didn't want to blow systems up. And that way they got to watch the load and see what it did, and then when they were ready, they flipped the switch and nothing happened. It worked great because it was already running. The customers were like, oh, cool, we got this new thing, or Facebook changed again, whichever side of that coin they're on. But the point is that they were able to do that. The other thing that's really important, and I can't stress this enough from a DevOps perspective, is feedback loops. I don't know who's on the system side or who has to troubleshoot stuff when things go wrong or what have you. But if you look at a log file and there's a log error and it says transaction failed, I want to kill you because that is not helpful. Okay, so for the developers in the room, as you're writing the code, create useful log messages We have these great services now that can go through these logs and parse them and give you statistical information and all this other stuff. You know, I/O is fast. We have SSD drives, et cetera, et cetera. Log all of the things. It's going to help you if you're doing all these deployments and something goes wrong. You need to be able to find it. So again, this is under the risk management heading. Also, run some of your tests against production. Go through and, maybe it's some of your journey type tests, so functional tests that log in and buy a thing and put it in the cart and da-da-da-da. Run them against production. Measure them. Is this working, et cetera. Why not? Now, there's even people, if you've ever heard of Chaos Monkey and there's other words. Netflix has a bot that goes around and just kills machines, just at random, and makes sure that the system can recover. And they do it on production all the time. I can't remember. They're all primates, but the big one, is it Kong? I can't remember. It takes out an entire data center. They don't do that every day. Okay, but they can flip a switch and an entire data center goes down. I don't know, is Netflix popular here? Okay, so in the US, during peak internet times, they are now using 40% of the total bandwidth. Okay, so all internet use, 40% is Netflix. And yet they can take down an entire data center and you won't notice. Features will go away. So they have those feature toggles and feature routers that we mentioned. They have things when performance degrades under a certain thing, it turns features off. You won't get as many recommendations. You won't get, et cetera, et cetera. It's a self-healing system. It's phenomenal, but you couldn't do it if you weren't constantly testing things. Another pet peeve, configure monitoring alerts to make sure people actually pay attention to them. This is the Chicken Little, sky is falling. If I get 5 emails a week from something that don't mean much to me, it's going in a filter. It's going in a folder where I promise I will make an attempt to look at it once a week, and the next time I look at it will be in July. I mean, it's human nature. And so make sure that the alerts are actually going to be paid attention to. And again, there's companies for this. PagerDuty, VictorOps, there's several that can look at all your monitoring systems and everything else, route it, they know who's on vacation. They can do text matching in the string and actually say, oh, that's the person that knows Oracle. There's great ways to do this, and it will help you. The next thing is to optimize all of your systems, optimize all of the things for recovery. So there's 2 phrases here, and I didn't ask him in time. There's a great graphic of 2 cars from John Allspaw. I didn't want to use it without explicit permission, but if you search for it, you'll find it. But there's mean time between failures. So how often do I think this thing is going to fail? If you're developing an aircraft, please pay attention to this. I'm going to spend 50 hours on an airplane this week or this month. So please optimize for mean time between failures. If you're doing there's how many, a million lines of code in the average car today? There are things that need to work or people die. But most of us aren't working on those systems. And so what we want to optimize to is mean time to recovery. When something does break, how long does it take me to fix it? Typically, the more deploys you're doing, the lower this is, because there's less code in the deployment. If you're deploying every 10 minutes or every 17 seconds like Amazon, and something goes wrong, then there's no rollback. That's a kind of a no-no in the purist continuous delivery world. Instead, you push a new change that might roll back the functionality, but you're not releasing version 3 because version 4 broke. Instead, you might take the code out and you're releasing version 5. But the time to recovery is much, much better the more deploys you're doing. Okay, so I think I'm probably ahead of schedule. That's what jet lag does. I talk faster. But again, the summary is it's not continuous delivery if you can't deploy right now. I mean, it just isn't. Words have meanings. And that one means you can deploy right now, or that phrase means you can deploy right now. We get to say that because our employees wrote the book. Practice good CI habits. I mean, you have to. A daily build is not continuous integration. Feature branches, again, by definition, words have meanings, is not continuous integration. Use things like the feature branches and so forth. I'm not sure exactly how much time we left, but we have plenty. I mean, that's all my slides. I have plenty of time for questions, I think. I do get paid by those guys, and that's where you can find out about their products. It's thoughtworks.com/products. Any questions at all? I can open it up.
it can't work with the old and the new, or maybe how do you solve that?
Okay, so the question was, you're making a database change and it can't work with the old and the new, how do you solve that? I'm going to couch this by saying I'm not a database expert. That said, we don't do that. So you're making a database change. What we really want to try to do is always be additive and deploy them separately from the application typically. Now there's going to be a lot of people that are going to disagree with that. But what I say is that, let's say you have a field that is name. And now you want first name, last name. You don't remove name. You add first name, last name. And then you make the code now write to first name, last name. In the read, is first name, last name empty? Yes, then read from name and display that. And prompt them to answer, to do this, whatever it is. And so they're both in there. And you let that soak for a while. You can do queries against the database to find out, what percentage is done, et cetera, et cetera. And then you do want to go clean that up. But so even those fairly radical changes, you want to try to do it that way. If you come see me later, there's lots of articles on that, because that is the hardest problem. Continuous delivery databases is by far, that whole category is the hardest set of problems. Yeah. Yes?
With feature toggles, is there a risk that you won't do any large-scale testing on your feature, and then it builds up over weeks and weeks and weeks, and then you're actually just doing a big bang deployment anyway when you turn the feature toggle off? Yeah, so the question is, when you're using feature toggles, is there a risk that you're not actually doing the testing on those, and so it ends up being a big day deployment anyway, because it hasn't been tested? Read that right? So one of the ways that we like to do that is we provide a way for the application to read from things like environment variables to the value of that toggle. And we have a pipeline or a set of tests that are running, or even jobs that are running in parallel. So these 3 test jobs use that version, these 3 use that version. And this is one of the reasons that we rarely will call the build system, the Gradle, Rake, Ant, Maven, whatever it is, okay? We will rarely call that directly. What we'll actually call is some kind of wrapper script, a shell script, a PowerShell, et cetera, that passes those things as command line arguments, for example. And so if we have a feature, we'll create another job. We have one product that's a SaaS product that runs 12,000 tests every half hour. And it runs on 65 machines in parallel. And if there's a high-risk thing, they will absolutely do that. And so what you want to do is you want to be able to set the value of that feature toggle programmatically. If you go to martinfowler.com, there's a very good article that was just written by a coworker, Pete Hodgson. It's on Martin's site, but Martin didn't write it, on feature toggles that goes into great detail that I highly recommend. It was just published like last month. Yeah. Other questions? Yeah. Without feature branches, what do you do with code reviews and pull requests?
So without feature branches, what do you do with code reviews and pull requests and so forth? Most companies that are doing really fast deployments, frankly, are not doing code reviews. They're doing things like pair programming for that part of it. Now, pull requests, that's a whole different ball of wax. So especially like on an open source project. So GoCD is an open source project, and it's on GitHub, and you can go do a pull request, and please do. That is not going into our main line to get tested every time. What it is doing is we have the continuous delivery server watching it, and when it sees a new branch, it does pull that branch and run a subset of the tests on it. And if that fails, then we send back to you, we're not taking your pull request, here's your failure. But if it passes, we merge it immediately. We don't wait until it's ready to deploy, we merge it. So there's actually, there's huge systems that have to do with the administration of Go, and there's a community member, I can't believe I can't remember his name because we owe him a lot. It's in like 170 pull requests. And they're every couple days and what have you, and they're managed the same way an internal one, except for that we're running those tests against it first. And most systems can do it. You should be able to, there's plugins and et cetera to do those kinds of things. Now, big feature requests, yeah, I mean, big pull requests. The person's probably going to give you a branch they've been working on for 3 months. And you can run it against the CI system, not as opposed to CD, run the unit tests or what have you. And then it's their problem to merge it at that point, which really sucks. And they should have been pushing every day so they didn't have that problem. Make sense? Okay. Other questions? Thought I saw a hand in the back. Maybe they gave up. Yeah.
How long do you think you should keep your feature toggles in your code?
Okay, so the question is, how long do you want to keep? Do you want to keep your feature toggles in the code? The shortest amount of time possible.
Yeah, because there's a famous example of a company going bankrupt
Yeah, they had a market. They had a market cap and cash of $400 million, and they lost $450 million in an hour.
It was 45 minutes they were bankrupt.
Yeah. It was a financial, I have that in the longer version. The blog entry, I have that in there. What they did is they had a feature toggle, and they didn't have good configuration management systems. They were like logging into machines and updating things, and one of the machines in their cluster didn't get updated, and so it was running the old code. And so it was like sending, it was actually a trading system. It was sending way more trades than it should have, and they literally went bankrupt. And they got acquired by somebody else and what have you. So yes. Ideally, you want to remove the feature toggle completely from the code, not just turn it on. I mean, as soon as you are confident that you're going to go forward. If you're in your system, that's 2 hours, awesome. If it's a week, okay. If it's a month, we should talk.
The actual problem, what happened there was they reused.
They used a name. That's right.
Feature toggle, and it was not removed from the code.
That's right.
And one of the systems was not updated, so it's kept running.
They called old code that had been dormant for years or something like that. Yeah, and don't reuse your function names. that's the other lesson from that one. Anything else? Yeah.
Use a special tool for feature toggle to have a console to administrate them and all that.
We use everything that you can imagine. So I mean, our company now, we're like the smallest company you never heard of. We're 3,500 people. But the average team size is 12 or 15. So, I mean, there are people that use command line, there are people that use automatic, like routing rules, every possible way. If you go to that same blog entry, though, he talks about feature routers and talks about the different ways to do them. We don't have an opinion which way is the right way. It's especially your tech stack's going to determine that probably more than anything. Yep. Anything else? Okay, again, we're on 5, so if you have any questions, be here the whole time. And then be back in 2 weeks at Pipeline Conference, because I like coming to London. Thank you.